The other thing I wanted to cover today was about photodiode and how we use a photodiode to sync stimuli. So if it was a direction tuning curve, it's a what we would do is we want to have so to give you a bit of background about how we use a photodiode, we have let's say a square part of this, a part in the corner of the screen that we want to hide from the animal, so the animal doesn't see it. But then and we put a photodiode in front of it to look at the specific part of the screen. And we can say we can then present on this part of the screen something that goes from black to white, let's say. And as you go from black to white, the photodiode is going to see that change in signal. And you can use that to know what happened when there was that change. You can then correlate it to when an event has occurred on the screen. So we use this kind of on and off signal to say like when the stimuli were presented on the screen. And it gives you a very precise time compared to any other strategy, because rather than saying when the computer has sent out the signal, you actually know when the stimulus was presented on the screen exactly. So you have much more precision in terms of, because there could be some delays between when the computer says present this on the screen and when the screen actually presents it. So here we kind of have a bit more ground truth as to when the screen is actually presenting a stimulus. And that's why we use photodiodes, which have been historically used in visual neuroscience. So in BonVision, the way we could do it is, again, it's actually really simple. I would use a node called DrawQuad. And so I'm just going to temporarily inactivate these nodes and just show a DrawQuad node. So now instead of so let's just say draw stimulus, and then I have a DrawQuad. Okay, so now in this case, we have a view window. Let's work that out. So let's make it a little bit bigger. So 10 degrees and 10 degrees. And it's white because it's 1, 1, 1. Okay, let me just play this. So there's a white square. Now we kind of want to move this square into the corner of the screen. So how do we do that? We can just let's move it to the left bottom. So minus 20. I need it further. That's too much. Okay, and now I want to move it lower. Should be minus 40, I think. Not too much. All right, so we've got this square. You can see that the square is a bit distorted and all that, and that's because it's kind of adapted depending on the position of the screen. We can avoid this, but I'm not going to do that at the moment. There's one thing, in general, in BonVision, we do have the option of putting layers, so we can overlay things. And so I would put this on an upper layer that is being presented on top of any stimulus. So even if there's a stimulus in the back, this would be the one that is presented last. And so this one gets priority. That's because we want to make sure that the sync is what is being shown, even if a stimulus if he by mistake places stimulus behind in that position, it just goes behind it rather than in front of the sync pulse. Okay, okay, we've put a quad in the position where we want to put the sync pulse. So when we put a photodiode, now we would put a photodiode looking at this part of the screen. Now, okay, so we've got this quad. I'm gonna just kind of make this a group. So let me first externalize some properties, and that's because we just want to convert. So zoom window comes in the way. So I just want to get the colors out. So R, G, and B, and let's just, I'm just going to create a float, and I'm going to make this maybe a subject. I'm going to call this quad state. And then I'm going to take quad state and put it into this one here. And I'm just going to say, okay, because I know this, I'm just putting IT. So I'm just going to show you what happens. This is black, and that's because the float right now is 0. If I make it 1, sorry, I can't see it. It's, sorry, do you see my screen fine? Because I've been moving this Zoom windows around.
Yeah.
Yes, to
All right, so you can see now that as you change the values, if I make it 0.5, it will merge into the background. Okay, so right, so that's basically defined this quad. And now what we want to do in this particular case is, let's say we want to have it go white or high when the stimulus turns on, in which case, in this case, it's the grating, and we want to go to black when the stimulus goes off. And that's what we want to done. So I'm going to activate this again. So I'll enable this to happen. I'm just going to make this just 2 repeats. That's easier. Okay, so now this is this variable called quad state. So take this out. Okay, so you've got draw gratings, take until this timer, and then you go at this other draw gratings, which is the 0 contrast stimulus. So we can just say every time this specific draw gratings, which is a full contrast stimulus, is on, every time this goes, we want it to go white, and every time this goes, we want it to go black. So let's make this thing, what I mentioned before, is a sync. So in this case, basically a sync does not interfere with the process. It just continues, but it will just be run every time this draw gratings is run. So I'll take this sync, I'm going to call it update photodiode. Let's call it PD for photodiode, update PD, yeah. I'm just going to call it that. And then inside update photodiode, I'm gonna have, basically, I just want to say, I can just do a float, and I'll say, it should be a behavior subject or replay subject. I think it should be a multicast subject. And this is going to be quad state. So, and then I externalize this property. I'm going to call it PD state. Okay, so now we've got this one. It's here, we've got this. I'm just going to copy it here. So here, when it's there, we want this to be 1, and when it comes here, we want it to go to 0. Let's hope this works. Yeah, it's doing exactly that. So it goes to 1 when the stimulus is on, and it goes to black when the stimulus is off. And we've done that by putting a sync in this, in the position after the stimulus comes on, and in the position where the stimulus goes off. So it's flipping between these two as the stimulus is going on and off. So basically, we can then record this, and based on that, we can get the required, we can sync up the two systems between the electrophysiology system or the imaging system using this photodiode. That's the basic way of doing the photodiode. Now, there are some other strategies which we might use, which is potentially kind of let's say we wanted to go on and off depending on whether the stimulus was, let's say we're presenting a movie, or let's say we're presenting, so I'm going to save this as a PD. So just to clean up this code, because I'm going to put it on, so this one I can just put it as a group, and I can call this PD sync. So that doesn't actually change anything. It's just got this code inside, and it's just activated every time. You can put this update PD at any point of the code, and that would do it. Right? So just going to save that. Are there any questions related to this photodiode bit? Okay. So just for for reference, I'm going to try and figure out this DrawQuad, which currently is at a very weird position, I think. Okay, there's the stimulus here. I'm going to move it minus 45. The reason I'm going back to this code is because it's got a slightly different strategy. I'll just put it a bit lower. Okay, so what is happening here? So this is basically every time we have a stimulus refresh, it is flipping from black to white. So you basically have the timing of every frame change in the stimulus. And it's basically the same kind of strategy. Here we've got this one, which is quad state, which is the same as before. But what we've done instead is here, actually, every time there's a render frame, we are in this group, we're just getting the element index, and we're getting a render frame count. Actually, more than that, it's here, trigger sync quad. So what this is doing is every time the stimulus is being presented, we take the index of that stimulus, and then we add 1 and we divide by 2. So it's just like every time this index of the element is even, you get a quad state going from add 1 and divide by 2. So when it's even, it's white. When it's odd, it's black. So we're just flipping between, every time the new stimulus is coming, it's just flipping between 0 and 1, and so on. So for example, if you were going to present a movie rather than this sparse noise stimulus, you can get the element index of the frame that is being presented and do the same strategy where you just flip the quad state on every frame of the movie that is being presented, going from black to white and so on in this sequence. So I know Phil Parker was asking me about this, about the movies being how the strategy for flipping the photodiode in the case of a movie, or when you have an established stimulus, a pre-designed stimulus, how you would do it, and that would be the strategy that I would use. Okay, I think that covers the 3 topics. We've gone a little bit over time, but I think that's it from what I wanted to talk about. Is there any questions related to any of the 3, or just BonVision in general, in case that can inspire the future live coding sessions? silence, I guess, is it. Just for okay, I have something logging next time. Okay, yeah. So actually, well, logging might be, so we can maybe cover logging as well. So Andrew, who's kindly joined us here from NeuroGears, we were talking about, so right now, the kind of strategy we used was just presenting a sequence of visual stimuli and a sequence of parameters. Now that works quite effectively when you're just changing one parameter. So in this case, we're just changing the direction of this in which the stimulus is changing, and that's fine. But let's say you want to change three different parameters. You want to change direction, spatial frequency, and contrast or location, all simultaneously within the same experiment. In that case, we want to create a matrix of stimuli that we're able to alter. So I think Andrew, the thing where we were discussing is that maybe we can cover a nice way of being able to do that in one of the next sessions. I guess logging is quite important right now, and it's definitely a lot of interest. So logging and that can maybe be the next session.
Yeah,
Does that sound good?
good. Yeah, I mean, we have a couple of strategies for logging. One is the one you showed there, which is that you, as your parameters are being generated, you're logging them to a CSV file or something like that you can read afterwards. The other way we do it at the moment is to define a kind of schema for the experiment in advance,
Yeah.
and log that. So you actually have kind of predetermined list of all your stimuli written in the schema, and that's the thing that gets logged. Obviously, if there's randomization, you also need to log that at the time of the experiment to be able to reconstruct everything. But yeah, that's our kind of general
I think
approach.
that schema is what we were hoping to cover in one of the sessions next. Because
Okay, cool. Yeah,
it seems this is new. This is the last time we spoke. I don't think the schema was established yet. So I'm looking
yeah, this
forward
is
to
quite
hearing
new.
about the
Yeah,
schema as well. Because we've got a few different stimuli that we want to create that would have the schema would be really beneficial for.
okay, cool.
I've kind of held back on some of the logging also because I want to know if we're going to switch to the schema, then I might have to change the way we decide to log things.
I see. Okay. Yeah.
Okay, great. Well, thank you all for joining us. Sorry for the last minute reschedule and all that. But hopefully the videos will be helpful for those of you who couldn't make it. Anyway, thank you all. Stop recording now.